Hello everyone! In today's tutorial, I will demonstrate how to use SolidStudio software to segment CBCT images. We will create high-quality, segmented views that isolate the teeth and bone, allowing for a clear visualization of extraction sites and anatomical structures. Before we begin, please visit the Solid Models Jordan channel and watch our SolidStudio Pro Basic Navigation video. Understanding the interface and navigation tips is essential for following along with the advanced segmentation techniques shown here. We start with the 3D view of the CBCT data, showing the axial, sagittal, and coronal planes. Our first step is to create a duplicate of the original data. This ensures that when we segment the files, we do not alter the baseline voxel values or lose any original information. Using the threshold icon, we can adjust the visibility of different tissues. Lowering the threshold reveals teeth and cortical bone, while increasing it isolates high-density materials like enamel and metal. However, a single threshold value often isn't enough. For instance, at a value of 1,375, you may see the enamel clearly, but the roots, which have lower density, might disappear or blend into the surrounding cortical bone. To solve this, we will create separate volumes for the teeth and the maxilla. Using the segment icon, we define our volume of interest. A bounding box appears to define the limits of the structure being segmented. You can resize this area by dragging its boundaries. In this step, we will isolate the maxilla into one volume and the upper teeth into another. After clicking Export, the segmented volume will appear in the volume list under your specified name. Next, we'll export a separate volume for the upper teeth. Simply resize the bounding box to isolate the dentition. Before exporting, verify that all teeth are fully contained within the box by scrolling through the slices with the right mouse button. Name this volume Upper Teeth and click Export. You should now see three volumes listed: main volume, maxilla, and upper teeth. Although they appear the same right now, we are about to begin the segmentation process to isolate the desired structures for each. Click the Solid icon, followed by the Edit icon, to open the Edit window. You will see the volumes we exported earlier, the maxilla and the upper teeth. We'll begin with the upper teeth segmentation. After selecting it, the editing tools will appear below. Start by selecting the Threshold tool. Finding the right threshold is a delicate and tricky task. With a lower threshold, the surrounding bone remains visible. As you raise the threshold, the teeth begin to separate, though dense bone may still linger. If you raise the threshold too high, you will hide that dense bone, but you also risk losing critical parts of the teeth, such as the root tips and softer dentin. Adjust the slider carefully to find the sweet spot where the teeth are clearly defined before the roots start to appear hollow or eaten. Deactivate the threshold icon to reveal the editing tools located beneath the volume list. Select the Edit Volume icon to open the Parameters panel. The primary objective of these tools is to remove unwanted structures, such as dense bone, from our volume. While some areas show a clear distinction between bone and teeth, others feature bone that is highly integrated with the tooth structure. To handle this, we will reassign the voxel values of the unwanted structures to a level well below our visibility threshold. In this case, we will set them to a value of 100. To begin, use the left mouse button to click and define the area you wish to delete. Once your selection is complete, simply double-click to apply the changes and eliminate the selected voxels from the render.
This area is eliminated because its voxels have been reassigned a new value of 100. To verify this, if you were to drop the threshold below 100, the geometry you just deleted would reappear in the 3D render. This confirms that we aren't truly deleting the data, but simply moving it outside our visibility range. Continue removing unwanted structures by rotating the volume and approaching it from different angles. It is crucial to maintain a safe distance from the root tips and adjacent teeth. This prevents the accidental deletion of critical anatomy, including structures that may be hidden from the current 3D render due to the threshold settings.
To remove structures adjacent to the root tips, we will switch to the Beam Edit tool. Unlike the Lasso tool, which assigns a fixed value, the Beam tool modifies voxel values by a specific increment. By selecting the Reduce function, we can gradually decrease the voxel values of the dense bone until it falls below the threshold and disappears from the 3D render, without risking the immediate deletion of the tooth structure. When the brush overlaps with high-density structures like metal implants or crowns, it will lower their voxel values. However, because we are reducing the values in small increments, such as 100 points, the metal remains significantly higher than our visibility threshold. As a result, the metal stays visible in the render while the lower density bone around it is filtered out. Continue filtering the dense bone from around the teeth by brushing it out from various viewing angles. For maximum precision, I recommend zooming in on the area of interest. You can easily adjust your brush size on the fly by holding the Shift key and using the mouse scroll wheel to scale it up or down. If you accidentally clip an area like a root tip, don't worry, you can easily undo the mistake. Simply switch to the Grow function to reverse the reduction. This increases the voxel values back up, restoring the structure to the 3D render. Now, let's verify our segmentation using the 2D slices. Use the mouse wheel to zoom in, and hold the right mouse button to navigate through the CBCT data. The segmented areas are highlighted in red, and you'll notice a cursor cube that allows for real-time voxel modifications. To align the view with a specific tooth, move your cursor to the edge of the green section line until the rotate icon appears. After rotating the slice, you may find that some anatomy, like the root tip, is missing because it falls below the threshold. To fix this, first hold the Control button and use the mouse wheel to resize the cube to the appropriate scale. Then, apply the Grow tool to increase the voxel values until the root tip reappears within the visible threshold. Since the 2D correction might have inadvertently included some unwanted bone near the root apex, we should return to the 3D view for a final cleanup. Use the Reduce brush to carefully eliminate any stray bone fragments, ensuring the root tip remains clearly isolated and anatomically accurate. Continue navigating through the slices to identify any hollow or eaten areas within the tooth structure. These gaps occur when internal tooth density falls below our set threshold. Simply apply the Grow tool to these regions to elevate their voxel values, bringing them back within the visible threshold range and restoring the integrity of the tooth. To achieve a more natural and refined appearance, we'll apply a blur filter to the volume. Setting this to 50% will smooth out any jagged edges or noise from the segmentation process, resulting in a high-quality, professional finish. After converting the volume into a mesh and assigning your preferred color, we can move on to segmenting the surrounding bone. Select maxilla from the volume list. You will notice the segmented teeth disappear, replaced by the unsegmented maxillary volume, allowing us to begin the next phase of the process. We'll begin by setting the appropriate threshold to ensure the bone is clearly defined. Once established, we will perform an extraction by using our previously segmented upper teeth to subtract their shape from the maxilla, creating precise sockets. To do this, click the Edit icon followed by the Extract button. Select Upper Teeth from the list, then highlight the entire volume area and double-click to apply the subtraction. Upon inspection, you will see the newly created sockets. However, the model may still appear cluttered due to metal scatter and adjacent structures like the lower teeth. To clean this up, select the Edit icon and click the Set button. Use the Selection tool to highlight these unwanted structures and manually eliminate them from the workspace. Rotate the volume and continue the elimination process from multiple angles to ensure a thorough cleanup. For more delicate areas, switch to the Beam Edit tool. This allows you to brush away artifacts with much higher precision, ensuring you don't accidentally remove any of the bone you wish to keep. For the best results, toggle between the Set and Reduce tools to maintain total control over the cleanup. Don't forget to continuously scroll through the 2D slices to verify your progress. This allows you to identify and perform precise brush strokes on any difficult areas that might be hard to see in the 3D view alone. To gain better access to internal structures, you can use the clipping option to isolate specific parts of the 3D volume. First, define your clip plane and click the scissors icon to open the clipping window. By setting the clip plane to an axial cut, you can hide the portions of the volume you want to protect, allowing you to apply 3D brush strokes only where they are needed. As you can see, we have successfully produced a clean, highly accurate segmentation of both the bone and teeth directly from CBCT data. This was achieved entirely on a standard computer without the need for server uploads or external processing. Thank you for watching, and I hope this workflow helps you in your digital planning.